Okay, welcome back, everyone. Well, I'm trying to configure my system. It seems to have worked. I only don't see my chat window. So. Let's see. There's still people joining. Okay, I'm looking at the wall of names, so I don't know whether you can hear me or not, but if you can't hear me, please let me know. Last week, or on Monday, we started with UML modeling. And today we're going to a completely different topic. So also the assignment for this next Wednesday will be completely different. Then we will do SQL programming. It's a sort of programming. So we're done with the UML now and start with SQL. I did it already for a bit in the fast forward version of the course. This time we will do it a bit more slowly. And the idea is that after today and definitely after next week, Monday, you will know an extra programming language called SQL. And on this Wednesday and the Wednesday after that, you will be doing exercises on SQL. The first time the exercises will be doing simple SQL queries. And the second time, the exercise will be about making a system or querying an interesting database with Bluetooth logs and try to find whether you find interesting results or things in that database. Okay, let's dive into the deep and start with this new language called SQL. SQL is a language that you use on databases, and a database is a thing with tables. And so the course today starts with explaining databases and tables, and then quite quickly we go to, I'll show you an example of a database that we're also using for the assignments and that you're supposed to install during or preferably before the assignment. So let's get started. First some terminology, then we discuss the elementary SQL statement, and once we know that, we're going to try that statement on the database. Okay, let's get started then. This is a table, and that's the basic thing of databases. This table has a name, or this table contains employees. That's the name of the table. And there's other things. The whole thing is called a table. That's the table name, but there's more. So a table has columns, and the table has rows, also called tuples. And the column is also called is a column or attribute. And on the top level, there is the name of the column or the name of the attribute. So these are basically the parts of a table that you need to know. And well, as I said before, a table in a SQL, everything is about tables. So tables go in and tables go out. You don't need to know much more. And then we go, how do we find answers on tables? How do we query them? Therefore, you need the SQL statement. And basically, a SQL statement looks like this. So select, it's always start with select. And then there comes a list of attributes. So here are the names of the attributes. And then a from, and there you get the table name. And then a where, and that contains a condition saying what rows of the table you want. So let's see that in practice. If we want to have the first name and the last name of a table of all the employees, of all the female employees, this would be a SQL query. And now we go to the database part. So in this course or in this lecture, I'm using a database called PostgreSQL, and it's you have to install it for the assignments on your own laptop. It's not very hard. I think the instructions are also part of the assignment. I already did that, and once you've installed that, then you have a sort of database server installed on your computer, and that database server is listening for people to connect to it. And therefore, if you only have a server, that's not enough. You also need the client software, which is also automatically installed if you install Postgres, the database that we're using. So now I'm going to show the client part. The server is running and you don't see it. And with this client, you connect to the server. And in our case, the client and the server are running on the same computer. So it's it's not much of a connection, but you could do the same via the internet. And the first thing I did when I connected to the database was loading the data that is needed for this example. And this is also exactly the data that you need for your first assignment. So if it's okay, I can run all the queries that we see here on the screen. I can also run them in the database. So, well, I'm going to give it a try. So I'm now starting pgadmin. That's the tool that runs that can connect to the database, and of course it opens in the other window. So I move it to your screen. It should be visible now. I found my chat window. I get a question whether you can use MySQL and whether there's any difference between MySQL and Postgres. Well, the answer is yes and no. So there are not many differences. There are differences between MySQL and Postgres, and one of the big differences is in the spatial part. So definitely for the first 3 weeks of your assignment, you could use MySQL, and then it becomes a bit different because well, this standard part of SQL is really standardized, and once you start doing spatial stuff with polygons, that becomes different. So for your assignments, the first 3 weeks you could use MySQL, and there's only small differences, but from that moment on, it's better to use Postgres. So this Postgres server is running in my browser. This is my browser. I can connect to different services, but I have only one running right now. It's version 12. And if I open it, I see that there are 2 databases in that server. I inserted all the data that I created for the assignment. I insert in database Quack. It's a default name, I think. And there's lots of stuff in databases, casts, catalogs, etc. You don't need them. So you move to the public part, and there should be the tables. And here you see the 7 tables that are part of this assignment. And what I'm going to do now is click on this table thing, and then click the right button, and I say I want to send a query to the database. So that's what I'm going to do. You get a new window, a query window, and let's type it directly. Select fname, name from employee where sex equals female. And then the slides were really picky about the semicolons, so I add them, but I think this tool does the semicolons automatically. So this done, I push the play button, and what happens then? This query gets sent to this database, and theoretically, or then we should get all the, well, let's see what happens. Just push the button. Takes a while. And I get no data. Why is that? I think I know now, because here in the example query, the F is capital, and in my query, the F is lowercase. And databases are really picky about the names, so let's find all the ones where the text equals big letter F. Try it again. Well, this looks better. So something works at least. And then I play a bit more with the tool. So in this query tool, because I can also click on the employee table, see what the data is in there. View data. Well, it's not a big database, so it's okay if I do all the data. If you have a database with millions of objects, you're not supposed to do it. So let's try it out. So this works. Well, I suggest you just play around with the database if you're going to try, if you installed it, and it should work. So you start basically with an empty database, and then you've got this big long SQL script that you can copy and paste to the editor for you to load this initial data set. Okay, I move away my SQL screen again and move it back when we are when I want to type a new query. So basically this works. So this query is human readable, that's nice, and it's easy to understand what it's doing. But how does it work from the database point of view? Well, actually, it does stuff in a bit of a weirdo order. So if you send this query to the database, what happens? First, the from clause gets applied. And in the from clause, there's a table. Each line is called a clause. Then the where clause for each row gets applied. And then in the end, the select gets applied. Well, what does it mean? Let's have a look at the table. Well, applying the from clause means just pick this whole table. And for now, this is the only thing you can do. But then if you have more than a query on more than one table, it sometimes becomes a bit more tricky. So the from clause just selects the whole table. Then the where clause gets applied. And that means that this where part is tested for each of the rows. And if it works, or if the where clause ends up in true, then the line gets selected and otherwise not. And finally, the where clause gets executed for each row, and that means that you remove all the columns that you oh wait, here there's the where clause part. Here's what happens if you do the where. Then all the rows are deleted for which the where is not true. And then you do the select part. And that means only these two columns get selected. Let's see what happens. Well, you basically throw away the rest of them. And then here in the top left, you have your resulting table. And yes, that's what you get back. So, well, basically this is it. This is SQL programming. And for the rest of the lecture today, it's just we're going to do extra stuff with more tables and more complicated where clauses, etc. So, but this is, if you know this, you basically can start on any database. And there are some tricky things. Sometimes you don't have a where clause, and then you can just leave it out. Or if you want to have everything from the database, all the columns, you don't have to specify all of them. You just say select star. Also quite convenient. And well, you can do both if you just want to see the whole table. And this is basically what people do when they open a database that they never saw before. You start doing this. Hopefully the table is not too big and it fits on your computer. And results are multi-sets. That means that, well, let's see what happens if we do this query, because what happens if you do this? Well, there are people with having the same salary. So the meaning of this multi-set is that if you have the same salary twice, it also gets printed twice. Let's see whether that really happens. We go again to this. We start doing a query. Select. SQL is not so picky like Python about where you start new lines, so you can put everything on one line, but don't do it, because then I cannot read your queries anymore, and also yourself will have trouble later. But this would work. Oh, wait, select salary from employee, of course. And I like laying out, so I do it like this. Push the play button again. And here you see you have the same salary twice, which looks a bit weird. So there is this other command saying distinct, and then you get them only once. Let's see whether this works. You see the result has become a bit smaller. Here you see it on the slide. Okay, so that was the start. This was really easy. Let's see about the main constraint. This is basically about creating the database. So each column, each attribute is of a specific type of or domain. So the social security number only contains numbers, and this always contains a date. And this you have to specify when you create a database. So this is how a database create instruction looks like. It's a SQL statement, and it starts with create table, and this is the name of the table. First name, 15 characters at most. Middle initial, only 1 character. Last name, 15 characters, etc., etc. Here you have a date, and the salary is a number with 2 digits behind the comma. So this is how you create tables, and if you see this, then you understand better how you can what you can do with the table. Because if you have a table with salaries, you can add them up, and if you have a column with salaries, you can add them up, and that doesn't really work that well if you have a column with names. It's a bit like Python, where you also have data types. So what kinds of types you have? Integers, floating points, real numbers. I see a question whether you can specify which format the date should have. Yes and no, not if you create a table. So it's, well, basically, if you create a table, you say it's a date, and then only if you print the data, you could specify how the date field should look like. And probably there is a sort of default value there, but you cannot specify it when you create a table. But most databases give lots of options to convert the data to any nice looking format that you like. We have Boolean values, date, time intervals, it's a start thing and an end thing, and many others. Then another question, why is it wrong to have twice a salary, since it corresponds to other employees? Well, yes, it's not wrong, and the only thing is that sometimes you want to have all the answers, and sometimes you want only one of them. So give me a list of all the cities where employees live, then it would be nice if each city would be there only once, if it's a big database. So it depends a bit on the on what you want. So sometimes you do a query with, and sometimes you do a query without the. I hear a question, I think, or not? No. Okay, so these are the basic types. All I'm going continuing with the slides. All databases know about them. And then here you have point, polygon, etc. They can also be stored in a database. They're not so standard, but they become more and more standardized. And they will not be part of my lecture, but they will be handled by Professor van Oostrom. And there's a lot of standardization going on in this world. So most things work on most databases. And here you see that the standard is already from 1992, and that's, oh my gosh, that's 28 years ago. So this language is older than most of you. So it's pretty stable these days. So what do you do with the data types? They determine the syntax and determine the operators. So you can add numbers, but you cannot add up strings, or you can concatenate strings by using this weirdo sign. And you can do calculations with dates. And here you have, this is this function for formatting dates. So if you want to only show a date as a year, then it works like this. And well, it's just basically a programming language. So the other stuff works as well. There's one thing which is often really nice. It's the like operator. And that's if you don't know exactly the name of someone, you use this one. It's really convenient. Let's see. I think I've been talking for 20 minutes now, which is basically more than you can handle, or about things you can handle. So I propose to have a 5-minute break. So I'll be back at 14:11. And this time I try to find the pause button on the thing. So I pause the sharing till 14:11. See you in 5 minutes. Oh, I think I paused the sharing of the screen and not the sharing of the... Now I pause the recording. That's better. Okay, see you in 5. Okay, I'm back. I didn't really disappear actually. I see a question on this chat on the UML assignment. I have to check that, and I'm not sure I will make it during the lecture. So if I forget, please remind me by email or so. So we're just still in this SQL thing. We know how to query tables, and let's see some additional features of SQL. So, well, this finding these female ones was easy, but like with other programming language, you can make it more complicated. So there you can use or and where, or and all the attributes together. And here you have an example of the like thing. So here you want all the ones where the address ends with tx. So in this case, from Texas. This one, if I copy paste this one, it wouldn't work because the space is missing here. So, well, that's kind of nice. And also in a query condition, you can use calculations. So, well, I wouldn't know when to use this formula, but someone invented this, so it's probably nice. And you can also use a value in the select part. So if you want to know, if you want to see if you were planning to give a raise for the next year by 10%, this would result in getting a interesting, or this would result in getting these values on your screen. Well, let's try that one. And now I have to do some tricky thing because no, I'm going to try to copy and paste this. Let's see what happens. Oh, it works. So I copy this. And open the browser again. Oh, it's here. I paste it to the query window and try to push the play button. It works. And then what you see here is you get a really weird column name, and that's not so nice. You want it to look nice. So what you can do is, if you do this, you can use the S keyword as next year salary and try it again. And it looks a lot better. So this stuff this stuff you can do with or this is useful for using the S thing. Let's continue again with the presentation. And here they do it. It's called aliasing. So basically, you get a new alias for the same column. And sometimes, especially with big tables, it's convenient to order stuff. That's also possible. So then your query statement becomes a bit longer. So it's select from, possibly where, and then order by. Also, you can order ascending or descending, sometimes convenient. And then there's a thing called null values. We discussed it a bit in the UML modeling, but also in SQL, it's quite important. So what do you have? Well, if you have a database and sometimes you have a value in the database and you just don't know the value, or the value is not applicable, or the value is not available or classified, or there's always reasons enough to am I looking at the chat screen? There's a question about table names always in caps. No. I think in 1992, when they invented this standard, there's a lot of stuff that is supposed to be used in caps. But these days, databases, they are a bit more flexible. And I think the database ignores the whether you're using capitals or small letters. And that's also sometimes not convenient. And then if you put single or I think double quotes around the name of a table, then it does not ignore the case of the letters. Okay, back to null values. Oh, sometimes you don't know a value, or it's not provided, or no, well, maybe this person doesn't get the salary. Let's see. And there's this one way of doing it, like you usually do in if you have a postcode, then you use the value 999ZZ for a postcode. And that's not so good, because there's this village in the Netherlands that gets a lot of letters because people are using this 999ZZ or another weird number. So databases are a bit more strict, and so there's a special value in all databases, and it's called the null value, and it means and it has a special meaning. So here you see someone's salary is null value. And basically, in all places where you can put values in a database, you may expect a null value. But sometimes this is not so convenient. So if you want to search by name, or I don't know, the student number in a student database, then it's really inconvenient if a value is not there. So you can explicitly exclude it if you design the table, and it looks like this. So here you create a table, and there's a first name, and it's not allowed to be null. And what happens if you insert a value where the value is null, then the database is going to refuse it. So if you have this table definition, then you can be sure that all the first names, they at least have a value. It may be a space or something, but there's always a value there. So that's very often convenient. And then there is this null arithmetic. So you can sometimes you have to test whether a value is null, or whether there's you do mathematics like multiply the salary by 4, and if the salary is null, then the result will be null. And if you test null in a test, then the result is unknown. And here, if you compare null, whether null equals null or is not equal to null, the value is unknown. So this null handling is a bit tricky, and I'm going to show you one example that you have to be really careful if you use null. And if you want to test whether a value equals null, you use the is. So not the equal sign like here, but you use is null. Otherwise, you get unexpected results. So let's try that on the real database. So we go to the table again, to the employee table. Let's view the data. Here we have a null value. So let's find all the people who basically do not have a supervisor. And then we would expect this. Let's see this. Oh, I think it's the Bohr guy. He's probably the manager of the company, because he doesn't have a supervisor. So let's try it. What was it again? That column does not exist. Let's see in the table SSN, super SSN. Try it again. And here you get all the values, and you get this bore guy. And now we want this one, we don't want it. So what we do is where super SSN does not equal null. And now we get nothing. Well, that's because if you compare to null, the value is always a bit weird. So, and now we try it like this, equals null. Again, we get not what we expect. That's because if you compare to null, you always have to use this if thing. So now we should get this Borg guy. Yes. And if you want the rest, it's not null. So you see, if you use equals in columns with where you can have null values, you always get unexpected results. So be really careful if you are querying a database with null values. I'm pretty sure that on lots of statistics that get published on databases, that the statistics are completely wrong, because people forget about the correct handling of null values. So always be careful when you publish data in a database with null values. And this slide somehow appears to be broken, but here you have the logic table and what happens if you use AND with true, false, and unknown. Because, well, yes, you have a sort of three-valued logic in a database. Everything can have three values: a value, true, false, or unknown. And then what does it mean if you do true and unknown? Well, you can see it. Okay. Basically, now you know everything about handling one table. I propose to have another break till exactly 2:30, and then we continue on having queries, doing queries with more than one table. And if you know that, then you definitely know enough to get started with your assignments. Well, that's then we need one final lecture for the more tricky stuff. But for till now, it's still doable as far as I think. Okay, see you in 6 minutes, 14:30. No, I don't want to stop. See you in 5 minutes. Okay, I'm back. And now we continue with the second set of slides about SQL with more than one table, because, well, just one table, it's a bit boring. So let's continue. Why would we need more than one table? That's a really start way, and then I describe how you do stuff with more than one table, and then a bit about how you refer from one table to another. Let's see about it. We start with the beginning. Why do we need more than one table? Well, this is a database with one table, and it contains a lot of information. And now it would be interesting to add information about the department, for example. So like the department manager, or the name of the department the person is working in, the manager, and well, lots of extra stuff. And you could do that easily by just adding it to extra columns. So the database becomes a bit bigger, but it works. So now you can do queries like give me all the people where the manager of the department started on February of March the 22nd. But it's not so good because it leads to redundancy. Lots of these values here are redundant, and that's really not nice, because then if you need to update that value, you need to update it in all the places, and well, you don't want that because you may forget one. So what do? Well, we stop the redundant data. We put it in a separate table, and usually if you do that, you get smaller tables, but more of them. And this putting redundant data in separate tables is called normalization. So this is basically the same database as the one on the previous slide, but it's normalized, and now you have a separate table with departments. And these two tables basically contain the same data as the table, the big table before. That's nice. But now sometimes you want to ask questions about the combination of the two tables. And that's where you get this cross, and that's called a join. And let's see how it works. So basically what you want, if you want to have the full picture, then you want to have the information on the employees with all the information of his or on his or her department. Well, how do we do it? You include direct references to the tables. So what you do in this first table, you insert an extra column with the department name, and that references the department here. So basically what you have here you say, well, the name of the department is research department, and then if you want to know more about the department, you go to the different table, find the one with research, and then you can see when the manager started and what the social security number of the manager is. So this is how it works. So how you combine tables, and now how you query that, that works via cross products and joins. So let's see how it works. Again, we start with the SQL execution model. We apply the from clause. And now here in the from part, there will be more than one table. And then we apply the where, and then we apply the select. And let's see what happens. Well, we start with the from. And now we need two tables, and where we do it for each row. Let's see what happens when you put two tables in the from part. Well, basically what happens if you do that, then as a result, you get every possible combination of this table and this table of each row. So you get this row with these values, this row with these values, this row with these values. You have a table of 3 and a table of 8. So you get 24 rows and 12 columns. Let's see how it looks like this. This is a bit too much. But then there comes the other part of the solution, and that's in the where part. This is called cross join or Cartesian product. It's big, and don't do it on big databases, because then you get big results. Because if you now do it on, you include the where part, where department name is this one equals this one, then you get basically back the result what you want. Because if you do that on this table, all the rows where the values are different, they get removed, and what you get then is this. And this is exactly what the table you wanted to have, or the big table where you started with. So this is basically the idea. If you do a select from two tables, then you get this cross product, or this combinatoric of this big explosion of data. And by adding this where you only select the ones that need to be connected together, then you get back to the result that you want. And so this is the first step of the execution of the execution model. And then you do the well, first you take the cross product, and then you do the where, which makes the selection, and then you do the select, where you select the columns, and that's where you get your end product. And basically this is called a join, because what you do is you have two tables, you glue them together based on one attribute. In this case, you glue them together based on this attribute. And well, we're into geometrics, so we like spatial data, and this will be discussed by Professor van Oostrom, because, well, this time the tables have only values, but if you have spatial data, this might be the village of the location of a person, and this here you might have the geometry of a city, and then you get stuff like select all persons and cities where the person is inside the city. So an equijoin always has a equal sign, but in the end we get spatial joins, and there you can have these nice stuff like inside, outside, distance, etc. But that will be discussed later. But still, the idea of a join is the same. So again, if you then do stuff with two tables, first you get this combinatoric explosion, and then it gets reduced again. There's one thing on these joins that we need to discuss, and those are keys and foreign keys, because usually if you point from one table to another, you want this reference to have certain specifications, like usually you don't want it to be null, etc., and you don't want it to change too often. So let's see how it works. So here again, this, by the way, is the only query that doesn't really work on the database, and we will see why. Because if you do it like this, so find all employees where the departments, and from departments where the department name equals the other one, then what happens if the name of the department changes? Here there's some redundancy again. Oh, I see. Wait, I see a question. Can we also join on supervisor social security number? Yes, we can, and we'll do it later in one of the examples. Again, so what happens if the department name changes? Well, this happens in reality. So what people usually do is they add an extra column with a sort of non-semantic identifier, usually a number. And let's see, here they have inserted department number, and instead of using the name of the department, you use a number. And so it's a special attribute for doing this. And you do not only do this in databases, but you also do this in reality. So that's why all students there, you have a student number, and all people in the country usually have a social security number. Cars have a license plate, and that's basically all because of the same reason, because it's a number, it's a simple identifier that doesn't that you have under control and that doesn't change too often. So so this is the trick. You usually add columns with an extra identifier. And then usually departments, they have these extra constraints. Each department the number of a department must be unique, so there cannot be two departments with the same number, and it cannot be null, this value. So this is really important for databases. So there's this database construction to make sure that this happens. So if you create a table for departments, then you add some extra stuff, like well, your department name, department number. It's an integer and it's not null. That's good to know. And the other thing is, it's unique. So if you create a table like this and you insert a second department, and may have a different name, but it has the same department number than one that already exists, the database is going to refuse it. So you can be sure that if you query the data, that each department has a different department number. And such an attribute is called a key. And most tables contain only one key, and by default, a key is unique and not null. And usually, if you want to refer to an object in a row, you do that by using the key value of that row, of that table. And here, there's even a shorter way of saying it. So here you have department, the create table statement again, and here you say department number is the primary key, so it's unique, etc. And then if you want to refer to that department number, so here you have the table with the department numbers, and if you want to reference it, it's called a foreign key. So this column is special again, because this column you want them to point to this department number, and okay, there should not be a value that is not inside this table. So all values should be 5, 4, or 1. In this case, this is the case, and this is called a foreign key. Well, a bit similar to like a key. It can be null, and it should always point to a value. And if you update the database, or if you change the data in the database, you should be careful if you alter two values, because if you remove a department, then this foreign key thing doesn't hold anymore, because there may still be people working in this department. So be careful if you update it, because the database is not going to like it, or the database is going to refuse your removal if you do that. So again, how does it look in a create table statement? Well, let's see. You have the employee, its first name, last name, etc., etc., etc. And here you say the department number. It cannot be null, so everyone is, and it references a value in the department table with department number. So by specifying like this, you can be sure that each person works in a department. And this is nice, because now you can put it in a sort of schema. And this is not UML, this is the predecessor of UML. So here you basically say an employee, the department number references the department number over here. And now let's see whether we can do it in a query. Let's see whether we can do the join. Again, here I have my query window. Let's first try with the combinatoric explosion. So let's find all the people that are with their manager, for example. So we need to table. Let's find all people let's find all the people with the name of the department. So we need two tables. Employee department. If I play this, this should result in the combinatoric explosion. Let's see. Oh, yes, lots of them. 24. That's okay. And then we add the where clause, where what was it again? Department no equals see it again. Okay, this is basically how it works. Now we only want to have the name, so we do the first name of the employee and the department name. So this is how joining tables works, and this is usually the way how you construct queries by just starting with the from clause and then do a where and then do a select and then update it a bit. So well, it's an easy language. Let's continue. So to be pragmatic, what very often happens if you do a query, then you first want to make sure you don't get this combinatoric explosion, and then you have other where parts. Usually you do the ones that do the join, you do them first. So here you see an example. So the where clause is used for two things, gluing tables together and then a select. And usually you do it in that order. So if you have a where part, then you do the gluing together first, and then you have your real selection. That's more convenient. And you can make it a bit more complicated. You can add extra stuff. It's still SQL. All combinations of all statements work. And now you come to this question, whether you can join other things like the supervisor, security, social security number, and other stuff, because employee has a key too. And it turns out that so the department has a supervisor, and it refers to the supervisor via the primary key. So if you want to have if you want the name of the manager of the department of an employee, you can also find it by using this query. And there's more arrows because here you have the supervisor, and this was the question. So this one I'm going to try out because this table is basically pointing to itself. So each employee has a supervisor, and now it might be interesting to create a query where you find the name of each employee and of the name of the employee together with the name of the supervisor. And here you see the solution, but it's a bit tricky, so I'm going to try it in this in SQL first. Here comes my SQL window again, because what we want is we need this employee table twice. We need it to find the name of the employee and to find the name of the supervisor. So what we do is, well, we have a sort of select, I know that, and I'm from, and then we have the employee table, but we need the employee table twice, once for the name of the employee and once for the name of the supervisor. So here I use this alias thing, because here I say first I use the employee table as employee, and then the same table again, but then as supervisor. And now I can use this. I use the same table twice, but now it has two names, because now you can say amp.name, comma super.name, and now you should get the names of the employees together with the names of the supervisors. Now I did something wrong. Oh yes, of course. Name doesn't exist. Your first name. Try it again, and it works. But then the table is a bit too long because I forgot to do this join thing. So I get really lots and lots, 64 8 times 8 values. So I forgot this where part, where, and now I have to look it up in the table above here, because what I want is the supervisor number equals the social security name. Okay, where amp dot super, I'm typing, why is nothing coming here? Now it should work. Where the supervisor social security number equals, let's see. And now you get exactly what you want. You get the names of the people together with the social security, with the names of the supervisors. Nobody is his own supervisor, no. So this is basically how you do it. And this is called an alias. And then, well, we noticed that sometimes it becomes a bit confusing, because this where part, you're doing two things. You're joining two tables and you're doing a sort of selection. And this is sometimes a bit tricky and inconvenient. So there's this special syntax in SQL to do the join in a different way. And that looks like this. So this part, these three things, employee part, you can write it in a different way. Okay, so this red part is called the join part, and this part is the selection part. And you can remove the join part by putting it in the from line. So this query and the previous query, they give exactly the same results, but this one is a bit more readable, because what you here basically say is you join the employee and department on a department number on these two attributes. So this, and then the where clause becomes a bit more readable. And well, then the SQL language tries to be a bit more natural language. So here in this is the slide before. Here you say join, and then you say which columns you want to join. And sometimes it doesn't look so nice. So if you have in two tables, you have the same column name, then you do not have to specify the on part, and that's called a natural join. So if there are two columns with the same name in two tables and you join, then it automatically chooses that column. And then you specify it like this, well, natural join on department. So it looks a bit better, but it's called syntactic sugar, because it's only a sort of shorthand. Okay, and now comes the tricky part with joins. And by the way, I think I'm almost done with the slide, so I'm trying to do it without a final break. There's this tricky thing with joins and null values. So let's see what happens. Let's take the example. Sometimes it happens that a foreign key has null values. Like here the case, there's this guy called Borg, and he doesn't have a supervisor. He's probably the general manager of the whole thing. And now what happens if you want to do find all people with their manager. Let's see what happens. Oh, Mr. Borg, he will be missing from the database because this null value is not there. Let's see whether that's right. I think that was exactly the query we did before. Let's see. Yes, this Borg guy is missing. This was queried. So can we fix that? Yes, and then that's when you get outer joins. There's many of them missing. Find all. So if you want null values to be included in a join, you have to use this outer join. So what you do then, if you do the query, then if table 1 has a null value somewhere, then it still gets joined to a thing with null, null, null in the right column. So in a left join, then table 2 of table 1 gets preserved, right join, table 1 gets preserved, full outer join, both gets preserved, and the inner join is the standard one. It's a bit tricky, so let's come with an example. Find all employees with the names of the managers. I already tried that, and the answer looked really nice. But it's wrong, so let's go back to the example. I moved back up. I first rewrite this query as a join. I'm not so good at doing joins, so I have to copy a bit. I think this should work. If I use the natural join, still no manager. And wait, I remove this, I make it star. No null values, but now I put here left outer join. Do it again. What's wrong again? I don't know what you. Oh, because it's not a natural join anymore, I have to put the on part there. This should work. Yes. Now we get the result, and now we get this Borg guy and lots of null values in the end. So put this one back, and there we have the final result. Oh yes, this is what we wanted. So it's a bit tricky, these null values, but by choosing the right join type, then it works. And this is one of the other places where null values may sometimes lead to unexpected results. So always be careful and look back at your data and your query if you get results that you do not expect. Yeah, well, this was basically it. But our example database has a bit more tables, and they get introduced in the coming slides. Well, this is the result of your query with the managers. Well, you can make it more complicated. List the employees with the names of the departments they manage. You get more nulls there because there's more Indians than chiefs. Well, you can do multiple joins because, well, this is the database is still a bit bigger. New table projects because people work on projects, and there are projects in these companies, and these projects have a location and the department of number. And it's a new base table. It has a foreign key again, and our project or our database becomes more and more complicated. And you have a query for employees working in departments having projects in Houston. Again, it's a sort of, you're joining 3 tables together, and for the rest it's basically the same. And well, the database becomes bigger because, well, departments have locations, and but one department can have more than one location. So where do we put them? Well, basically the answer always is then extra table. So we get the extra table with department locations. This table is a bit tricky because it doesn't have a primary key, or it does have a primary key, but the primary key is a combination of both columns. And then the primary key is called a composite key. And well, each table has a composite key, and usually you try to make the key as small as possible, so you remove all attributes that are not needed for a key, and that's called a candidate key. Again, the department number is a foreign key referencing department, and now our schema becomes more and more complicated. Foreign key can be part of primary keys. Find all social security numbers of managers department located in Houston. And well, again, it's more of this. It's more of the same. It's all the SQL statements you know already. You only have to combine them in different ways. And the tricky question is, do you want to put this thing there or not? And well, you can just try it out on the database, but I think that there might be managers that manage 2 departments, both of them in Houston, and then you would get this manager twice. So yes, I would put this thing there. That's a bit the way of thinking about where to put these things. Again, a query finds all managers, the social security of managers of departments located ending with a D. Well, it's more of the same, so I'm skipping it. Whether it needs to be discount, yeah, let's see. Comes another table on the database, dependents. All employees, they have people that depend on them. That's the family members. We put them in an extra table, and I think this is basically the end. And now you know all the tables that you're going to need for your assignments. Oh no, there's one more. A cross table time spent in projects. It's more complicated again. This is how much people spent on projects, and it's a bit. You use the same trick again. We have a composite key of 2 foreign keys, and then besides that, there's an extra attribute, number of hours. This time, I'm pretty sure this is the final database. So these are all the tables and all the ways they are connected, and this is basically what you're going to use during your assignments. And I think if you want to, you could already start, but I haven't assigned you to groups yet, so I'll do that this afternoon. that's basically it. So now you know everything about querying one or multiple tables of a database. But next week on Monday, I'll show you there's still stuff that you cannot do, and we'll discuss that on Monday. So yeah, well, enjoy your weekend. The weather doesn't look that nice, but I'm going outdoors anyway. So have fun and see you on Monday. Okay, bye. I stop the recording.